Hello, this is Camille Fairborn from Michigan State University, and I'd like to welcome you to today's CAUSE Teaching and Learning webinar. I'm pleased to introduce Dr. Matthew Beckman as our speaker today. He is an assistant research professor and the chair of undergraduate studies in the Department of Statistics at Penn State University. For today's webinar, he will give a presentation entitled Capstone Assessment for the Undergraduate Statistics Major. The way the webinars work is that all listeners are muted during the webinar. You can ask questions at any time by typing them into the questions box. We'll be sure to ask those questions towards the end and give Dr. Beckman a chance to respond. You can also use the chat box if you are having any technical questions. At this point, I'll turn things over to Dr. Beckman. Matt, go ahead.
Thank you so much, Camille. I appreciate the kind introduction. And I should have mentioned that I may have a couple of spots within the presentation to kind of open things up for discussion at a couple of different milestones. So please feel free to make a note, and if you have a question, and we can of course chat about them when we get to a convenient spot for that. So the page that I'm on right now is just a little GitHub web page with the resources for this webinar. So if you'd like to take a screenshot of the QR code or just a screenshot of the page or scan the QR code, I should say, then you'd have access to all of this afterward. I'll just keep it up as a public page so that you can refer back at another time. And each of the resources that we'll talk about are linked here, including the slides and some other tools related to the assessments that we developed as part of this project. So I'll come back to this page periodically, I think, but if you do want to grab a screenshot of that, then you can at least save it for later. And I think Camille mentioned that she would be able to tag the URL in the chat window. There it is, at the beginning and at the end for your benefit as well. So the goal here is to share some of the work that a group of us have been doing on capstone assessment for undergraduate statistics majors. And it's been a collaborative effort across several institutions. And so I'm grateful for contributions from lots of terrific collaborators, and also for some funding support from the Penn State Center of Excellence for Science Education. And the main goal of the work was to measure learning outcomes of students on completion of an undergraduate statistics program. So for us, that looks like a major. Other places it might be an emphasis, or it may be a minor, but whatever you consider to be an undergraduate statistics program, that's kind of what the starting point we wanted to begin with. So in doing so, we want to come up with a snapshot of student learning outcomes, hopefully facilitate some cohort comparisons across years at the same institution, or any other comparisons that would be relevant. And we wanted it to be as comprehensive as possible. So that means we're going more broad than deep in a lot of ways. And so the constraints that we were interested in included alignment as close as possible to the ASA curriculum guidelines for undergraduate programs in statistical science. So we're trying to borrow heavily from that document as the authority on which topics and which domains are most pertinent for a high quality undergraduate program. So that it wouldn't be just left to the personal opinions or the judgment of the team that was creating the assessment tools and resources. We also want it to be easy to use across institutions, and easy to use for just different instructors or different years at the same institution, which is of course valuable as well, because different instructors are open to different tools, and if we can have something that can be used consistently, scored consistently, and compared equitably, that is an outcome that was high value for us. And so at this point, some of the outcomes of the work include 2 capstone assessment tools. So one of them is a direct assessment, like a test, and the other an indirect assessment that is a self-reported type of survey. And we have a few years of pilot data. It's still a little bit early, but we do have some good pilot data, we think. And at least so far with the early pilot data, The psychometrics look promising, so we think that we're asking questions that align well to our goals and that they're functioning as intended in general with the student groups. So if you haven't looked at the ASA guidelines for a while, I wanted to show at least a snapshot of a page that helps to illustrate our approach to the process. So the guidelines in some places, in particular page 12, which I grabbed for this snapshot, has a lot of lists, and this page in particular has lists of lists. And so this was one of our first activities in trying to come up with a test blueprint and trying to evaluate what does comprehensive mean under the constraint of the authority of the ASA guidelines that I mentioned before. And that meant going through each of the lists, finding everything that was mentioned and acknowledged as an important competency, I'll call it. And sometimes those appear in the body of the text, but oftentimes there are many footnotes or side notes, margin notes, that also include things that should be included. So, for example, the margin note 51 says multivariable calculus is recommended. Margin note 52, Markov chains are a useful topic. So those sort of things should be included because they're in the scope of the document as topics that or competencies that a high quality undergraduate statistics program might include. So in completing that task, we identified 95 competencies in the ASA guidelines. And so it was immediately clear to us that a single assessment tool is likely not sufficient to assess all of them, at least assess all of them with good properties and good data. And so this is a link, but instead of clicking it, I'll just go to the tab. So to show you how we set up the blueprint, so we identified the ASA curriculum guidelines. This is just a view-only Google Doc right now, but the ASA curriculum guidelines organizes those competencies along 6 sections. So statistical methods and theory, data manipulation and computation, or data science, and so forth. Those are the kind of major sections that they use to organize those competencies. And within each of those major sections, there are often many subsections. Like in statistical methods and theory, there is a subsection for statistical theory, or exploratory data analysis, or design of studies, and so forth. And so you can see here that we're outlined. This is where we're kind of cataloging where everything appears in the document. And as I scroll through, you can see in particular in the next section that there are a number of topics that are referenced many times throughout the document in different sections and so forth. For example, the software and tools using professional software, that sort of thing is referenced in a number of places. And this was our goal for this document was, one, to provide the traceability of where these things are coming from, and 2, to organize them in a way that we could start to think about how heavily each of them should be weighted. So it's one thing to start with a comprehensive list, but that doesn't mean that everything on the list should have equal value. And this is where the team imposed their judgment to discern which things maybe should have greater emphasis for our purposes in the assessment tools, at least, than others. So you can see some of those weights at various places. You can see kind of the marginal weight of each major section, and then you can see the weight within. So given the statistical methods section, 30% of the statistical methods section weight should be attributed to statistical theory, for example. And so you can multiply them and see what the weight would be for each subsection, if you like. But that was the approach, to just so that we could start to balance how much content should be addressed on the assessment aligned to each of these sections and subsections, and even more specifically, these topics or competencies, as I've been calling them. So I mentioned that we developed 2 assessment tools out of the gate. One of them is an indirect assessment, so it's a self-reported survey, and effectively it just asks students how comfortable are you with these 95 competencies, just as they're aligned in the ASA guidelines? And I'll show you an example of that in just a minute here. But it's self-reported data. It's very fast, so it only takes students 10 or 15 minutes to complete the survey. And you can even give that survey to several cohorts from a single institution. That's kind of a nice thing about an indirect assessment, a survey tool like that. We also developed a direct assessment, which is the CUSP test. CUSP we're calling Comprehensive Undergraduate Statistics Program Assessments. And so the CUSP test is a selected response test. So in some cases, the tasks are, mainstream multiple choice, select the best option from A, B, C, and D. In other cases, there will be a number of a kind of a shared prompt and a number of tasks that are related to a shared prompt, and the student may be asked whether some statistical model or approach or interpretation is valid or not valid, given the context of the prompt that's been shown to them. And I'll show you an example of that as well. The testing is more expensive in terms of student time. Students are likely to develop test fatigue if we try to ask everything we want to ask for something that has such broad coverage as the test that we're developing here. So we're trying to keep it a little bit lean, and 1 hour we thought was reasonable as kind of the most we could expect of students without really getting too close to that issue of test fatigue. And we do have some data for multiple institutions, each with typically a single cohort. And one of the institutions that has been participating has data for multiple cohorts in our pilot round of data collection. So beginning with the indirect assessment, the CUSP survey, so the benefits, it's easy to implement. You can administer it multiple times if you want to. There's no problem including topics that we don't teach. That's kind of a nice thing. If I go back to the blueprint, there are things here that may not show up in our curriculum or your curriculum. And if you're just asking students on a survey, do you know anything about regularization? They don't mind saying no if it's not at all in the curriculum. And so the survey allows an opportunity to ask those sort of questions, and we don't have any sort of conflict in including things that aren't otherwise expected of them in the major or in the program. So that's I think a significant benefit of the survey, the self-reported survey. And furthermore, we can include demographics. So I show the survey over here, and let's see, I guess I was looking at it before I signed in, and I think I skipped past the demographics. I wonder if I can get, yeah, there we go. Okay, so we can ask demographics. So students would arrive on a page that asks them for consent. I'm going to decline because I'm just presenting the survey. I don't want my data to be used for any other purpose. If you'd like to use it, let me know, and I can include you here just so that students can find their institution. And so Penn State, for example, where I am, we've added maybe a conditional question where we can ask something specific about their major or emphasis if that's of value to us. At another institution, if that hasn't been provided to us, then we'll just get the regular demographics that include academic standing, GPA, and their sex, how they'd identify race and ethnicity, the education level of parents and guardians. All of this is optional. So I can fill out none of it and skip ahead, and that's not a problem at all. But if students choose to provide it, then that's useful information for us, for you. So the survey, as I said, is very much an inventory of all the topics you had seen in the test blueprint. And so that's exactly how we designed it, that we're looking at statistical methods and theory, and statistical theory was the first bucket within that that section. And so you can see each of the tasks or competencies, the competencies or topics that showed up are now appearing, and students can self-report whether their current level of knowledge or competency is anywhere from very low or never learned it, all the way up to exceptional. And so students are able to self-report. Self-reporting, of course, has some reliability questions. You may be concerned about over or underconfidence associated with content exposure. Even something like lexical ambiguity, like a term that might show up and mean a specific topic, could lead students to feel more confident that they know it, but really they don't know what the technical term is describing. For example, maybe regularization, that has a specific technical meaning that you might think of tools like lasso or ridge regression that shrink parameter estimates in order to improve the bias variance trade-off. And if students aren't familiar with that, they might think of regularization as something like, oh, they must be talking about normalization, where I just standardize it, mean center and divide by standard deviation or something like that. So that could lead to higher variability on some of those topics with which students are less familiar. But if you know which ones those are, then you can adjust for that or downweight how excited you might get about the type of responses you might observe on those tasks. So that's more or less what the survey looks like. Again, it's indirect assessment. At Penn State, at least, we're sharing this with students in our first year seminar. So their very first semester, they've identified they might be interested in a statistics major. Maybe they stick with the major, maybe not, but we can ask them the survey and get kind of some data at that point if we choose. We don't yet have a good midpoint course. I'd like to get there where we have kind of a checkpoint partway through the curriculum to invite students to provide some feedback on how they feel about those topics. And then we do have a capstone course at Penn State, and at least right now, we're asking students to complete the survey at the beginning and the end, because it doesn't make any difference if they've seen the survey already. They can just report how they feel about those topics. And so that's a really nice thing about the indirect assessment, that you can use it multiple times. There's no test security or anything like that. So to the extent that the data is useful to you for information about the program or students' growth as they work through the program, then it can be a helpful tool for that purpose. Oh, good. So I was afraid that I would blow right by my opportunities for discussion. And so my recent self was kind enough to leave a note to ask Camille that we could open up if there are any questions at this point, specifically about the indirect assessment, before we kind of move on to the direct assessment and things like that.
Well, okay, we'll stop here. And if you have a question, there's a questions box there in the side of the screen for you. Go ahead and type those in if you have one. Now, Matt, you were saying you have some good data on this already. Is there anything really interesting that you've seen come out of the indirect assessment so far?
So far, most of our analysis, so we were more excited about the preliminary analysis of the direct assessment.
Okay, that makes sense.
So we've spent more time thinking about that one, which I'll talk about next.
Okay.
And I will mention, well, that one thing that we think could be pretty exciting about the indirect assessment is the ability to link student identifiers from the indirect assessment to the direct assessment. So in a direct assessment like a test, it's a little bit awkward to have students spending time answering demographic type questions, but it seems totally fine to do in the context of a survey. So we can get the demographics in the survey and apply them to the test when we can link students by their email address or something like that.
Okay.
So there's some benefit to that.
All right, well, we've got a couple questions. First, does the survey allow for transgender or non-binary student gender identity in the demographics section?
That's an excellent question. And so I am always, I want to be sensitive to, so not only the gender identity topic, but also race and ethnicity topics. And so I personally tend to defer to whatever the US Census has been using, at least at the time when I developed the question. And because I feel like they have the experts that study what is most appropriate in that context. And so right now, there's not a non-binary option, but students are not required to answer. And so that's an imperfect solution, but that's the state at this point.
Okay, and then the other one asks, could you see your indirect assessment being used in graduate programs? For example, a master's in statistics or biostatistics.
Sure, there's absolutely no reason that it couldn't be. So we've been pretty forthcoming about tying our objectives to those ASA guidelines for undergraduate programs, but certainly I've even had conversations with the grad program chair at Penn State and some others that just to discuss, would this be useful to you? Because the outcomes of an undergraduate program might be useful as either an assessment at the beginning or somewhere in the middle of a graduate program. Beginning is a little bit hairy because we don't expect necessarily for a graduate program that students have already studied statistics. At least a number of graduate programs, as I have had the discussion, will say, we're going to teach you the statistics. We want to make sure you have the foundations and the raw material to learn that content. But we don't assume that you've had a lot of exposure prior to the program. And so that can be a little bit challenging for where to put it in a graduate program. But certainly I think it's low cost to ask, 10 or 15 minutes of investment from the students and getting some interesting information about what they feel comfortable with and what they don't. I think there's no reason it couldn't be used in that context.
And then one more, does this map to specific institutional learning objectives that PSU may have for their program? Or is it just going off of the ASA guidelines? Or I'm interpreting that question to be, did you put a lot of Penn State stuff into your assessment, or were you trying to keep it more general?
We were trying very hard to keep it more general. So, for example, there in the test, which I'll kind of move to next. We considered questions to be fair game, even if they're not in the Penn State curriculum, and we felt completely fine with that because it's in the ASA guidelines, and I can stand in front of my students and have and defended that decision with a rationale that maybe you can give me some feedback when we open up for questions again. But the rationale is that even if it's not in, if it's in an elective, say, that's really where it might come up. Or a student might say, but I didn't take time series, so can we really have a time series question on the test? Is that fair? And my reasoning to share with them was that the type of questions about specific methodology that we're asking in this kind of test are not down in the details, even at the level of, suggesting that an ARIMA model or something like that would be useful in a specific time series scenario. It's at a higher level of just recognizing that the data are correlated in time, and this is a place where time series would be valuable. And so that sort of intuition that data are correlated in time, this is a place where time series would be valuable, is the type of intuition we would expect from a graduate in the program, even if they have not completed the time series course. In my thinking, as I share with them, is, when they go to work, if this problem comes across the desk, you can't push it back and say, oh, that was an elective and I didn't take it. You might just have to recognize the context and teach yourself a little bit. So I'm not expecting them, and we didn't expect them to have detailed knowledge of those sort of topics that might be on the fringes of the mainstream curriculum. But we'd like to see if they have good reflexes to identify them when it's appropriate. So that's kind of the approach for that sort of topic. So we tried not to tie ourselves too closely to any individual curriculum at any of the institutions present, but really tried to let the ASA guidelines be the North Star. And then all of us can evaluate our outcomes against that. And I'll even get to a point here soon where I'll share a little bit more about what I mean by that. But so this direct assessment, the CUSP test, as we've started to call it, is all selected response. And so that was a decision that we made in order to serve one of our objectives for institutional comparisons or for cohort comparisons, that it doesn't matter who's teaching, doesn't matter who's administering. It's the selected response is scored in exactly the same way, no matter, there's no rubric interpretation or something like that. Now that gives us a really challenging constraint that some of the topics just are not appropriate. Some of them are really challenging to ask in a selected response type of tool that can be administered to everyone, but some topics just aren't even appropriate in that context. And so you know, for example, if I go back to the blueprint and if I look even just at the major sections, discipline-specific knowledge, for example, we have a pretty low weight on that. So these weights are aligned to the test. When we decided we were going to use this for a test, the survey was going to include everything, and the test was going to be weighted based on the judgment of the group. And so discipline-specific knowledge, well, students may go to very different disciplines. And so how can we ask in a specific way something that would evaluate that outcome of all students? And so that's the type of challenge that I'm talking about, where some things are not appropriate, and certainly other things are just hard to ask in a selected response. And so that kind of foreshadows a future need for maybe other tools to come and join these as a more comprehensive assessment profile. But what we've landed on for now are 33 tasks. Some of them have multiple parts, so 9 of those are testlets where you have a shared STEM or a shared prompt, and then a number of tasks that to which students are responding, maybe to say whether some interpretation or some intuition is valid or not valid in the context. And then 24 of them are more conventional multiple choice, that you select the best choice out of 4 or 5 options or something like that. Now, with so few tasks and so many competencies, we did try to evaluate or write tasks that could address multiple competencies, but we did not assume that a task that evaluates multiple competencies does so symmetrically for every competency that it evaluates. So we kind of imposed this adjustment that if a task, a specific question on the test is relevant to 3 different competencies, then maybe, you know, we give it the full weight of that point or that task toward the primary competency that was in our mind when we were writing the task. But then for a subsequent competency, maybe only half of the weight toward that competency, or a fourth toward the next. And this is kind of an assumption. This is something that in the future we would like to evaluate closely. This is just a decision that we made out of the gate, just because we didn't want to you know, overestimate the ability of every task to evaluate multiple competencies. And so we did this diminishing return idea. But whether this is the right way to specify the diminishing return or not is something we have not yet studied, but something that could be useful. And so since there are multiple tasks, multiple these testlets that have multiple responses, and things to that nature, the overall assessment has something like 86 points possible. The number doesn't really matter, but that's kind of where it landed. Most of them are original tasks, but I do want to thank Felicity Enders and Bob Delmas and colleagues for allowing us to adapt some items from other instruments, Regress and Chaos namely, which are included in the assessment tool, and further provide some further benefit because they kind of benchmark something that's already existing. So I can show you a preview here of the test, and it does require a password. And so I'm happy to share that with you. You know, there's a risk that I type the password wrong and then be embarrassed, but I'm happy to share that with you, of course. But the password is really primarily a reminder just for any instructor that wants to review it. So the password is confidential. It's the word confidential. So for any instructor, my hope is that when your hands are typing that word, you'll remember, oh, I shouldn't share this link with all of my students. I should go get a direct link for my class. And if you'd like to do that, I'd be glad to get a direct link for your class. And that makes it possible for me to protect your data from being distributed to any other class or for any other purpose, or for different classes to cross-pollinate their data or something like that. So the direct link is really for your benefit, and we're more than happy to do that. But this is the extent to which the demographics go in this case. So they have to put their name on it. And these are used primarily to provide this feedback back to an instructor, so that if you wanted to use this as some sort of for credit in the class, that it'd be identifiable who had completed it. And so this is kind of what the assessment looks like. I'll just page through a number of these. You can see there are a few here that have a shared STEM with multiple tasks, and some with one STEM and one task. Snapshots of software and things like this are available kind of throughout. So these are examples of the sort of tasks that students might encounter on the assessment, and I'm kind of paging until I might find a chaos task. They sort of appear in a group, but they're not at the very beginning. So at any rate, these are the type of, there we go, there's chaos. So we have a few chaos tasks that were not selected randomly, but were selected in the judgment of the team to be tasks that we had known even senior students to still have some trouble with. So that's totally non-random. It's a convenient sample for the sake of mapping growth beyond the introductory curriculum, but a true benefit, in my view, of including a built-in chaos subtest is this idea that you have, so this CUSP test would not be appropriate to administer in an introductory curriculum. It also is something that, once students have seen the task, the cat's out of the bag, and you can't really reuse it in the way that you can with the survey. So having a built-in chaos subtest allows you to do a little bit of a growth comparison if you decided to include something like chaos or goals, since they share a number of items with one another anyway, as a baseline in your introductory curriculum, so that you can at least have a shot at observing the growth of students on that subset of tasks or subset of issues between the beginning and the end of the program. So that was the reason that we included that. And we do find it helpful. We haven't done detailed analysis of that with our students at Penn State, but others have said that was very valuable to them and had appreciated that subtest opportunity within the CUSP test. So the goal here is an objective measure of student competencies aligned to the ASA guidelines. So for individual students, they can get, what we do is after they've completed the test, we give them a summary card. I don't even want to call it a scorecard. Truly, I try always to call it a summary card or summary report. And this is something then that can be handed back to the students, and it's just an auto-generated analysis of every student that completed it within a cohort, so within a class. The first page includes their name and their email address and is otherwise totally innocuous. So if you wanted to hand it back in class, then it doesn't matter if they're in a stack and other people see them or something like that. It shows the test blueprint and explains something about the test and how it's designed and that sort of thing. And so I spun up this demo student, and you can see that there is sort of how did students in the cohort do against the ASA guidelines? What was their number correct, or their percent correct? And then the number of item touches since these are all stat students, and so they would know that something with only one item touch is a more highly variable estimate than something with 11 item touches, and so we give them that information. And then the individual student has their little summary card as well, where they can kind of get a little bit of a kind of overall score and a rank among their peers in the class and things like that. But these are kind of crude metrics for them, but they get a summary card where they can see where are things, going well, where are things a little bit softer, again, with the constraint that there aren't that many items on any given topic, so they shouldn't be taken, too literally. But the idea is for students to just see where do they look, how does their result look against the ASA guidelines? How does their result look against the other students at their institution who are graduating soon, if this is used in a capstone context, and likely to be on the job market at the same time, or things like this, so they can just see what's going on. And it's a summary card because it should be used as an objective tool to just say, boy, I had trouble with the probability section. Maybe I should revisit my notes and see if I can brush up on my probability theory or the skills related to that. So we don't want to oversell this. We don't want it to be high stakes, certainly, but we want it to be a summary report that our students can benefit from. And we also have, I guess I didn't include the snapshot here, but we also have an institution summary report, which gives them, which we can share with instructors to show it's a little bit more detail, just a little more detail about the institution and those sort of results. And so when I said before that, we don't mind if there are a couple of tasks that aren't necessarily included in the curriculum. Well, if I don't have any access and data wrangling, topics in the curriculum or any courses that stress that content, then if the summary card comes back with a 0, then I have a choice to make. If that's not in the curriculum because we don't believe it's important, so what? If it's not going well, but we do think it's important, then we have a decision to make. Do we go and look at where the students are getting this content and where we can give them additional exposure to the content or things like that. So it's not to be high stakes in any sense, but the goal is just to have some kind of objective summary of how well our students are learning what we think we're teaching them. And if there are things that we don't think we're teaching them, then it's an objective snapshot of that too. And so that's really how we try to position the utility of the tool. So it's designed to be easy to implement. The aggregate data then is useful for things like program evaluation, where I'm making decisions about the undergraduate program at Penn State and talking with the undergraduate program committee about changes or new courses or things like that. And so it can be useful for those purposes, but also it gives students just kind of a snapshot of how they might line up with their peers in the room in hopefully not a high stakes way. So that's really what we're trying to accomplish here. So in our use case, at Penn State, I mentioned the indirect assessment, but at Penn State, we actually use the direct assessment, the test, as a midterm in the Capstone course. Now, midterm is a strong word, and we sort of use it on purpose as a strong word, but it's only worth 10% of their grade. So we've made a decision to position it this way, and in part because I had been teaching the Capstone course when we decided to introduce it, and I felt like, if it was a midterm, if I could convince my students to study for this, meaning one time, go back, dust off the old notebooks, and read through each of the notebooks from the stat courses they had taken in the past, even if they only do that one time, if that's the only thing that changed, I felt like they would be a stronger statistician when they graduate than if they had not once, at the very end, kind of reviewed things with now the larger perspective of the entire curriculum in their mind to try and synthesize and fit things together. So that was a big part of the motivation for us positioning it as a midterm. Now, 10% is not high stakes as midterms go, and we do curve it. It's, you know, it's a challenging test, and so for this type of assessment, when it's norm referenced, you want to expose variability, and so the mean is something like 55%, just like it is for chaos or for goals or other research assessment tools. And so we curve it so people get fair grades, and we haven't had any problems with that from students to this point. But yes.
I'm sorry to interrupt you, but we really are almost out of time.
Oh dear. Okay. I'm sorry. I had the wrong time.
Yeah, we need to close up. Do you want to just kind of
sure.
wrap up a little bit?
Yeah, I'm happy to wrap up. Thank you. I appreciate that. Okay, so we positioned in this way because we wanted students to prepare. Others have done it in different ways and had success in getting useful data from that. But that does, importantly, undermine cohort to cohort, institution to institution comparisons. And so you should be wary of that if you decide to use it for that way. So I was going to open it up here for discussion anyhow. I will just kind of zip through. Item analysis looks good. So in general, the items function quite well. You have the slides, and so you can go back and kind of look at this. Some of the things that were surprising out of that was that a task about probability distributions was the most discriminating task on the entire assessment. And some of the ones that were not discriminating, there's one that was just wordy and, you know, maybe needs to be rewritten. And a couple of others that the chaos task that didn't function especially well, we need to investigate because that's kind of in conflict with what chaos reported for that task. So we should find out if there's something different about this use case versus theirs that would present that issue. And another that didn't function well, the strategies to maximize likelihoods just doesn't have a lot of correct answers yet. And so a larger sample will give us a better indication of whether or not the item discrimination is any good. So we have plans for future work. I'd rather open it up to some discussion and hear some feedback, comments, and things like that. So after thanking the many folks that have participated in pilot testing and advisory direction on the tools, it of course would be a much different outcome without their help. So we're all very appreciative to them. Then I'll leave the balance of the time for comments, discussion, or questions. Camille?
I'm not talking. Oh,
yes,
sorry.
There you are.
Okay. Did anyone hear? My announcement didn't go through?
No, sorry for that. I haven't heard you speak after I stopped.
Okay, I'm sorry. I've been talking to myself then.
Okay.
If you have any questions, I just need to announce that coming up in 2 weeks, we have our new inaugural sponsored webinar series that CAUS will be doing. So starting on September 24th at 2 p.m., our first webinar will be sponsored by JUMP and will be entitled Data Visualization, an Essential Component of Data Analyses. And we hope you'll register for the webinar and attend at the usual time if this topic interests you. We appreciate our sponsors and the ability they give us to make CAUS possible. We also have a full slate of other webinars coming this fall semester, so I hope you will keep your eye on the CAUS website and join us as often as you are able. And it doesn't look like we have any other questions, and I am out of time. So thank you, Matt, for your presentation today, and I hope to see everyone next time.
Okay, thank you.